Hi everyone. Old friends are gold, new friends are diamond. If you get diamond, don't forget gold because only gold can hold a diamond. By saying this, let us start your mathematics class. In the previous session, we have discussed regarding commutative and closure property. Let us discuss in this session regarding associativity for addition and multiplication. In the commutative property, we have learned if you add any whole numbers or if you multiply any whole numbers in any order, you will get equal result. In the same way, if you consider associativity, in the associativity what happens, you can observe here. If you take 2 plus 3 plus 4 is equals to 2 plus 3 plus 4. In the LHS side, you can observe here 2 and 3 I have grouped as a one part. In the RHS side, I have grouped 3 and 4. 3 and 4. It says that what? In the associativity, if you interchange the group and if you add, whether you will get equal result or not, we have to check. If you interchange the group, in the LHS side 2 and 3 I have made one group. In the RHS I have made 3 and 4 as another group. If you interchange the group and if you add means you will get equal result or not, we have to check. Now we can see here 2 and 3. 2 and 3, you know that how much 2 and 3? That is 5 plus 4 as it is equal to 2 plus 3 plus 4, 7. According to BODMAS, we have to simplify the inside part of a bracket first. So we simplify bracket. Then next what happens? We have to add 5 plus 4. How much? 5 plus 4, 9. 2 plus 7, 9. 2 plus 7 also a 9. Then therefore LHS is equals to RHS. LHS is equals to what happens? RHS. Now by this what we came to know that if you interchange the group and if you add, then you will get equal result. So we can say that for any whole number, not only a 3, 2, 3, 4, any whole number A, B, C, A plus B plus C is equals to A plus B plus C. A plus B plus C is equals to what? A plus B plus C. Therefore, whole numbers satisfy associativity under addition. Whole numbers are satisfied associativity under addition. Next, if you consider subtraction, if you consider for subtraction, the same process if you consider for subtraction, you can observe here I have taken 3, 2 and 1. In the RHS side also 3, 2, 1 I have taken. Here 3 and 2 I have grouped as a one group. Here 2 and 1 I have grouped. Now what happens here? If you subtract 3 and 2, what you will get? 1 minus 1 as it is equal to 3 minus as it is 2 minus 1 is 1. 1 minus 1 is 0. 3 minus 1 is 2. Whether 0 is equals to 2? No. It is not equal. 0 is not equal to 2. In the LHS side we have got 0. In the RHS side we have got 2. So LHS is not equal to RHS. By this what we came to know that whole numbers are does not satisfy associativity under subtraction. Whole numbers are does not satisfy associativity under subtraction. Next, in the same way, we move on to what? Multiplication. In the multiplication, what happens? Here also you can observe here I have taken 2 into 3 into 4. 3 numbers I have taken. Those are 2, 3 and 4. If you interchange the group here 2 and 3 I have made one group and here 3 and 4 I have made another group. So you can see here 2 3s are 6. 4 as it is equal 2 into 3 4s are 12. Now what happens? 6 4s are 24. 2 12s are 24. Either LHS is equals to RHS? Yes, LHS is equals to RHS. Then what we came to know that for any whole number, A, B and C, A into B into C is equals to A into B into C. Then whole numbers are satisfied associativity under multiplication. If you take any whole number and if you multiply in any order, in any group if you multiply means you will get equal result. So we can conclude that whole numbers are satisfied associativity under multiplication. Next, if you come to division, you can see here I have taken 4, 2, 3. 4 divided by 2 divided by 3 is equals to 4 divided by 2 divided by 3. 4 divided by 2 is 2 divided by 3 is equal to 4 as it is divided by 2 and 3. 2 and 2 by 3 I have taken. So LHS is equals to RHS? No, it is not equal. So we can conclude that whole numbers are not satisfy associativity under division. By this, what we came to know that whole numbers are satisfy associativity under addition and multiplication. Whole numbers does not satisfy associativity under subtraction and division. Next we move on to identities. Identities, then what is meant by identities? First we will go for additive identity. Additive identity. Additive identity is nothing but you can see here some of the example I have taken. Here 7. For 7, which number if you add means you will get sum as a 7 only. Can you say that for 7 which number if you add you will get 7 only? That is none other than which number? That is 0. 0 if add to 7 means you will get what? 7 only. Then for 9 if add with one number you will get 9 only. Which number if add means you will get 9 only? That is 0. 0 plus 9 is equals to what? 9. Therefore 0 is called identity element for what? Addition or additive identity or additive. So why 0 is called identity element? Because if you add any number with 0 you will get the number itself. So because of that reason 0 will call what? Identity element for addition or additive identity. Identity element for addition or additive identity. Next, for any value a. For any value a plus 0 is equals to a is equals to 0 plus a. For any value a plus 0 is equals to 0 plus a. Shows that what? If you add any number with 0 means you will get the number itself. Next, multiplicative identity. Multiplicative identity is what? 6. See, you can see here for 6 which number if you multiply. For 6 which number if you multiply means you will get 6 only, that is 1. For 10 you have to multiply with one number means you will get 10 only. Which number that is? That is also 1 only. You can observe here. So therefore 1 is called identity element for multiplication or multiplicative identity. Because of that reason we will call what? 1 is called identity element for multiplication or multiplicative identity. 0 is called additive identity. 1 is called multiplicative identity. For any value a into 1 is equals to a is equals to 1 into a. So I hope you all understood associativity and additive identity. Next we move on to distributive property. Next we move on to distributivity of multiplication over addition and subtraction. You can see here for all whole numbers, what happens? For all whole numbers a, b and c. For all whole numbers a, b and c, a into b plus c is equals to a into b plus a into c. A into b minus c is equals to a into b minus a into c. For example, if a is equals to 4, b is equals to 3, c is equals to 2. You can see here distributivity means what? A into b plus this a we have to multiply with b also, we have to multiply with c also. Then what happens? A into b plus a into c. A into b minus a into c. Then if you take example means if a is equals to 4, b is equals to 3, c is equals to 2. First we will with respect to addition we will check a into b plus c is equals to a into b plus a into c. Then in the place of a we have to substitute 4. In the place of b we have to substitute 3. In the place of c we have to substitute 2. Then a into b, what happens? A is equals to 4, b is equals to 3 plus as it is. A is equals to 4 into c, that is 2. Then 4 inside bracket first part we have to simplify 3 plus 2, that is 5 is equals to 4 3 is a 12, 4 2 is a 8, 4 5 is a 20, 20 plus 8, 12 plus 8, sorry 20. Therefore LHS is equals to RHS. So therefore we can conclude that a into b plus c is equals to a into b plus a into c. In the same way, if we take for with respect to subtraction one example, what happens if a is equals to 4, b is equals to 3, c is equals to 2 only have taken. Substitute the values. A is equals to 4, b is equals to 3, c is equals to 2. then A into B is equals to 4 into 3, A into C is equals to 4 into 2. Then 4, 3 minus 2 is 1, 4 3 is 12, minus 4 2 is 8, 4 1 is 4, 12 minus 8 is also a 4, LHS is equals to RHS. Even here also you can observe here, LHS is equals to RHS. Here also LHS is equals to what? RHS. LHS is equals to RHS. So we can conclude that for distributivity for all whole numbers A, B and C, A into B plus C is equals to A into B plus A into C, A into B minus C is equals to A into B minus A into C. I hope you all understood about associativity, distributivity and identities. In the next session, we will discuss regarding these properties problems. If you have any doubt, you can ask children. Thank you. Keep watching our YouTube channel. Bye bye.